Alright, so here are some of the properties of inequalities. The only one I'll remind you of is if you multiply or divide by a negative number with an inequality, you've got to flip the inequality symbol. Alright, so the easiest one, a linear inequality, we are going to start off by subtracting 3x from both sides to get the x's to the left, and then we're going to add 7 to both sides to get the numbers to the right. So now we've ended up with 2x is greater than 16, and you guessed it, divide everything by 2, and we get x is greater than 8. Alright, so I'm going to write it out using a number line. That means an open circle at 8, and then shade to the right. And then if we want to write it out using interval notation, this is an unbounded, so we would put a parenthesis, because we don't include the 8, up to infinity. Alright, so same type of problem, but notice here, we got fractions. We're in Algebra 3. We should all be able to handle fractions. So with this one, I'm going to start off by subtracting 1 from both sides. And I'm going to go do everything one step. I'm going to subtract x from both sides. So that will give us negative 5 halves x is greater than or equal to negative 5. So that now we can multiply by the reciprocal. So we'd have to multiply both sides by negative 2/5. And remember, put x, now we're going to put less than or equal to because we multiplied by a negative. And again, we can make this on a number line. And this time we would put a closed circle with 2 because we're including it. And then we would shade to the left. And if we're going to do interval notation, we would start off with a parenthesis and put negative infinity because this thing goes down forever, up to 2, and we would use a square bracket to include the 2. Alright, so a double inequality, we do the same thing. So I'm going to not talk and speed this up, but we just do it twice. Alright, so now we've got our two values here. So if we're going to put these on a number line, we'd have a closed circle at 1/3, an open circle at 2/3, and we would shade in the middle because 1/3 is greater than or equal to, and 2/3 is less than. Pretty straightforward so far. I had to bring my kids to work with me today, and I'm not going to lie, they're getting on my nerves. I had to kick them out of the classroom so I could record the audio for this. And that's it in interval notation. Alright, so hopefully you guys remember absolute value inequalities. I'm just going to let you read this, and then we're going to do an example right after this. So we're going to call ones with less thans and problems. And these always end up shading in the middle. So the second one, these are greater than, so we're going to call these or, greater than. In the or problems, you always shade shooting outward, so there's always a gap in the middle. Alright, so here's two examples. So notice A is an and problem, so when we're done with that, it should be shaded in the middle because it's less than. B is a greater than, so it's an or, so it should be shooting outwards. So remember, the first step of solving absolute value inequalities is we need to split it apart into two inequalities. We're going to keep one inequality the exact same. I always put that one on the right. And then the one on the left here, I'm going to flip the inequality and change the sign of everything on the right. And hopefully we know how to solve this. I was trying to make the thickness thinner on the pen, but it doesn't work. So x is greater than 3 and x is less than 7. So notice the inequalities. So greater than 3 means an open circle at 3 going to the right. Less than 7 means an open circle at 7 going to the left. So these two are shaded in the middle. Alright, so our next problem here, the interval notation, 3 to 7, do the same thing. But since this is greater than, our answer should have a gap in the middle. The shading should be shooting outward. So we put an open circle at 3, an open circle at 7, but notice less than 3 means we need to shade to the left, and greater than 7 means we need to shade to the right. So notice how there's a gap in the middle there. And we're not going to worry about interval notation of this because we have talked about how to write those yet with this situation with a gap in the middle. Have fun reading that. I'm going to take a more graphical approach than doing the test value here, but you can totally do the test value. And don't forget you can use Desmos online or some sort of graphing utility online. If you have an Android device, you can install WabbitEmu. Again, you can pause the video if you can't read it that fast. Alright, so step 1 is get it everything to one side. So I'm going to subtract 12 from both sides. And you guessed it, I'm going to use the box method to factor this. So I'm going to speed up the video for that. Alright, and I'm back. So hopefully everybody knows how to do the box method. If not, send me a message and I will send out an explanation to you. That's something we've been working on since Algebra 1. So this thing factors the x plus 4 times 2x minus 3 is greater than 0. So what we're doing is we're finding the values that make it 0. So hopefully we know x equals negative 4 and x equals positive 3/2. So that's our two intersecting points we have. So this is where you can either do the test points or take the graphical approach. I'm going to take the graphical approach because I know this is a quadratic and it crosses at negative 4 and 3/2. And I don't really care about all the other points. I'm more worried about where does it cross the x-axis and when is it above 0. So I'm going to draw a picture real quick here, maybe. It's like I forgot how to spell the, or no, test. Start spelling the. Alright, so this is just a quick sketch of the graph. We know it crosses at negative 4 and 3/2. And again, notice the inequality in our problem says greater than 0. So we're worried about where it's above 0. And the Skype's popping up. Awesome. Let's get rid of that. So notice it's above 0 from negative infinity to negative 4. So, and starting at 3/2, everything above 3/2, it's above 0 again. So we could write that out using our interval notation or inequalities. Is totally up to you. At negative infinity to negative 4, and then from 3/2 to infinity.
Hello.
Hello.
I just wanted a marker because there's only one in my mom's room.
That's fine. There's that interruption they talking about again. So notice if it was a less than 0, we'd be worried about where it's below 0. So it'd be -4 to 3/2. So notice we don't use square brackets because 0 is not, we would have to have an equal sign there. All right, so more fun here. We're going to get everything to one side. And hopefully you're looking at this thing saying, I know that's got 4 terms. We're definitely going to have to do factor by grouping with this. And if that's what you were thinking, you're exactly right. I bet Randall's already asleep. Alright, so we're going to group the first 2 terms together, group the second 2 terms together, and make sure we put that negative sign with the 32x. We don't want to put that in the middle. You know, that goes with the 32x. Alright, so we factor out what each binomial has in common, x squared and -16. Notice how both signs flip in the third part, or in the second binomial. Alright, so notice we can factor the difference of squares to be x plus 4 and x minus 4 is greater than 0. So now we state the values and make it 0. Positive 3/2, -4, and positive 4. So again, we can do test points in between all these values to see which ones are greater than 0, or we can just think about it or look at it in our calculator or think about it logically with a cubic function. So I know this thing is crosses at 3/2, -4, and positive 4, so I'm just going to do a quick sketch so I can get a visual idea about what this graph looks like. So put my important points there, -4, 3/2, and positive 4. Alright, so now I'm going to draw my graph. Just a quick sketch. So all the values that are greater than 0, if you look at that, we can see it's greater than 0 when it's greater than -4, but less than 3/2. And then once we get to 4 again, it's above the x-axis, so we'd be greater than 0 there. So we could have interval notation from -4 to 3/2. And then we could write, 4 to infinity. Randall's definitely asleep. Alright, so these are all special cases. They all kind of have weird things going on with them. And again, you can factor them or look at the calculator, kind of get an idea what the special deal is. So this one is always above the x-axis. It doesn't cross the x-axis, so it's from -infinity to infinity. It's infinite solutions. Again, you can type it in and look at it if you don't believe me. Alright, second one. We get to factor this, and we get it's x plus 1 times x plus 1. When is that less than 0? Or less than or equal to 0? And we only have one solution at x equals 1. So it touches the x-axis at, at 0, or at -1. And then it opens up. So there's only one value where this thing is less than or equal to 0. And that's at -1. So one solution. Alright, so C. Sorry. Come on. There we go. It's the empty set. If you graph it, you'll notice it's asking if it's less than 0. This thing is graphed completely above the x-axis, so it's never below 0. So empty set or no solution. Alright, so the solution set of this one here, we could factor it and get x minus 2 times x minus 2. So notice this has one point at 2 and it opens up. So when is this thing greater than 0? Well, there's only one point where it's not. It's when it's 0. So the only thing we could say would be x cannot be 2 in this situation. That was fun, right? And we'll worry about this problem if we ever come back to class. You guys have a good day. Hope you're feeling better. I hope you're not sick, I guess I should say. I'm just assuming everybody has the coronavirus by now. Just kidding. But stay healthy.